Welcome to the deep dive. Today we're digging into some pretty interesting technical documentation.
Mm-hmm.
Our mission really is to quickly pull out the core insights on these PT8010 series systems. They're advanced environmental monitoring systems. We want to understand, what makes them tick and why they're such powerful tools for managing our environment.
Yeah, and what's really compelling here, I think, is how directly this stuff impacts our daily lives. When we talk environmental monitoring, well, often that means the air we breathe, the noise around us.
Exactly.
And these systems, they're built on high precision tech. You've got light scattering particle sensors, great for counting and sizing tiny particles. Then there are electrochemical sensors for specific gases and PID sensors too.
PID sensors, right, for volatile compounds.
Exactly, yeah, volatile organic compounds. And crucially, they use active pumping sampling. They literally pull the air in.
Okay, active sampling.
Which is, vital for getting that precise real-time data you need for, say, regulatory compliance.
Okay, that precision is definitely key. So what exactly are these systems watching for? The list in the docs seems, well, incredibly comprehensive.
It really is. On the particle side, you've got PM 1.0, PM 2.5, PM 10. Those are the ones everyone worries about for health.
Respiratory health.
Right. And even TSP, total suspended particulates. And the range is huge, up to 50,000 micrograms per cubic meter.
Wow, 50,000. That's a lot.
It is. It means they work in relatively clean city air and in heavily polluted industrial zones, or like during big dust events. Then for gases, they cover SO2, sulfur dioxide, think industrial emissions, NO2, nitrogen dioxide from traffic, carbon monoxide, ozone, nitric oxide, and TVOCs, the total volatile organic compounds.
So very wide net on the chemical side, too.
Definitely. Covers a lot of bases.
And it's not just pollutants, is it? I saw mentions of meteorological monitoring.
Yeah, that's right. They can integrate sensors for temperature, humidity, wind speed, wind direction,
Okay.
plus noise monitoring and even video feeds.
So how does pulling all that together help? Having weather and noise and video alongside the pollution data.
Well, that's where you get the real power, the full context. Imagine a construction site.
Okay.
You're not just seeing dust levels spike. You see the wind is picking up from the north, carrying it towards that neighborhood, and maybe the noise levels are exceeding limits.
Right. So you see the whole picture.
Exactly. It makes these systems super versatile for cities, industrial areas, factories, mines, you name it. It gives you that complete real-time snapshot.
And the system structure reflects that complexity. The docs talk about 3 layers.
Yeah, basically the 3 parts. You've got the front-end perception. That's all the sensors collecting the raw data.
Got it.
Then data transmission, getting that info securely where it needs to go. And finally, the intelligence service layer. That includes the management platform where, all that data turns into something useful, actionable insights for you.
Right. Turning raw numbers into actual understanding.
Precisely. And this layered approach, it's smart. It means the system is robust, scalable, flexible. You can add new sensors later, things like that. It's all designed for real-time, remote, automatic monitoring. And you can access all that data wherever, desktop, laptop, even your phone.
Okay, so we've got what they monitor, how they're built. Let's really nail down what makes them so effective, so actionable for people managing these environmental issues.
Sure. Well, beyond just collecting data, it's the advanced features, like automatic fault diagnosis.
Meaning it spots its own problems.
Yeah, exactly. It flags issues itself, which minimizes downtime. Huge benefit. Then there's the remote control side. You can change warning levels, push software updates, even troubleshoot the system all remotely.
And this linkage function sounds really interesting for practical use.
Yeah.
Connecting to other systems.
Yes,
Right.
This is pretty cool. It means the system can automatically do something based on the data. So like if dust levels surge on that construction site, the monitor could automatically trigger, say, a fog gun machine to spray water and suppress the dust.
Oh, wow. So it acts on the data itself.
Right. Or maybe activate a fence spray system, and you can tweak those rules remotely. It makes mitigation proactive, not just reactive.
That seems like a big step forward. Proactive control.
It really is. Plus, they mention a data collection effective rate over 99%, so it's reliable, and GPS positioning, so you know exactly where each reading is coming from.
Okay, that's quite a package. Comprehensive monitoring, remote control, automated actions.
Mm-hmm. Which kind of brings us to a final thought, maybe for you, the listener. When you have this level of precise, real-time environmental data you can act on remotely, how might that change things? How could you use that kind of information not just to track problems, but to actually empower communities or industries to actively cut down on pollution and, create healthier environments.
Yeah, what would you do with that kind of detailed, actionable insight at your fingertips? Something definitely worth thinking about.